I'm happy to introduce Flavia and Jasper from Aknostic. They were very kind to give this guest lecture for us. So the way I asked them is as a bridge from digitalization to sustainability. So sustainability was already discussed in the previous guest lecture, but I'm sure that Aknostic is another angle. So the floor is yours. Thank you. So you hear, just check your voice.
Can you hear me on the?
I think you have to speak up to be sure that.
Can you hear me?
Yes, we can hear you loud and clear.
Okay. Okay, let's a brief introduction about us. We have been working together for over 20 years. We are both studied something similar to some do computer science. We are software and cloud engineers. Yes, we're also hardware engineer. And we founded this company, Aknostic, which is a relatively small consultancy, cloud consultancy. Work together later on an IoT company for agriculture, for growers to help them grow their crops efficiently. Later on, a couple of years back, I joined a non-profit focused on sustainability on IT. That's where I learned a lot about this industry, or this aspect of our industry. We also joined the CNCF sustainability group. So we are trying to and we are back in Agnostic actually now, and we are trying to do things related to sustainability in different ways. I also put here a picture. These are some books we co-authored on Amazon Web Services, because back when we started the company, which had another name, we were focusing on AWS and how to build infrastructures so that they were very resilient and strong and robust. And the funny thing was that, well, architecture and design was a big part of that, but also the possibilities that the clouds give you in terms of running several servers in parallel, and so to be resilient, to be ready for failures. That was also one of the points of some of these books, and many years later you revisit that and you think, okay, so what's the sustainability impact of that? That's what we want to talk about now. Very brief. So we're going to talk about how we help the digital transformation. What are the side effects from the point of view of sustainability of digital transformation? What is our motivation to change or to help this in a more sustainable way? And we're going to talk about something we are software that we are working on to measure and estimate emissions of software across the whole spectrum. Which open source software we use for that, and we mention a demo. And we will also talk about some challenges, because this is a complex goal. What we do is they are sitting in the sun next to the canal in Utrecht, but sometimes we also do native Kubernetes-based consultancy. This is our company in Utrecht, and we help companies in their digital transformation with the cloud. So you should have learned already, according to Patricia, what digital sustainability is. So can someone tell me what it is?
For digital transformation.
Digital, what did I say?
Transformation, yes.
Yeah.
Anybody?
My goal is the digital fall asleep, so this is necessary. Yeah, you want to say something?
Yeah,
Okay.
I think it's a process of it's digital transformation, right?
Yeah, also.
Yeah. It's a process of converting things from analog to digital space.
Yeah, exactly. So using digital technology, apply it to their business processes.
Yeah.
To innovate, to improve performance, etc. Perfect. So you know it. How do we do that? Well, I took an example from an educational platform. We have a customer which has basically a digital platform which supports 25 million students in 12 different countries, and they basically they have systems or applications for everything from the teachers to the students and everything around it for primary, secondary, and also higher education. And in this kind of context, it's very important that the systems are very reliable, that they can handle loads, because if you're a teacher, if you're a primary school children and you are, for example, doing a test and then you lose all your work because your EC2 instance is gone, and this is this is not acceptable. So we are helping companies like this to satisfy all these reliability demands and load, because imagine that you have in the Netherlands there is a few weeks where I have primary school students. There's 3 weeks during which they have all their official exams, and that's the same for all the children in the whole of Netherlands. So at the same time, say at 10 o'clock, all the students log into the system and try to do an exam. So we have to make sure that the resources are there when they need it. Obviously, with the cloud, it's easy to over provision or to be a little bit extra careful, and then have maybe use too much of these resources to be able to satisfy this needs. In general, this is an example, of course, but what happened is everywhere in the world we have been moving towards digitalization, in particular involved with cloud. But this the consequence of this is that we have been needing to build more data centers, we have been needing to manufacture more hardwares, we have been needing to consume more electricity. And all of this requires not only renewable, but also non-renewable resources such as metals and minerals. So the photo in the background is a cobalt and copper mine in Congo, and this is it's not nice. I mean, the people who have to mine these minerals, there's consequences beyond just what we think about CO2 or global warming, right? Sustainability is not just the environment. Sustainability is the people. And I don't know if you already saw the sustainability goals, but you will see them. And the people is part of the equation. So to give some examples, I'm sorry, I'm going to be also a bit negative, but for example, over provisioning, there was a study very recent on Kubernetes clusters, and they were looking at how much the available processing power was being used. And they found that only 13% of the provisioned CPU was being used, and only 20% of the memory. So over provisioning is a thing, no? It's as maybe developers or engineers, we think, okay, let's be on the safe side, then we don't have to wake up in the night. We in our jobs, we do have to wake up in the night. But this is a bit ridiculous. If we look at the electricity consumption, we see the consumption of electricity of data centers can be compared to that of the electricity consumption of whole countries. So it's almost close to the UK. Well, this is data from 2020. Perhaps it's worse now. So this is it's big. It's beyond, you know, that we talk about brain coding, but it's the data centers, it's everything. Hardware. This is also about how many data centers, or in this case, hyperscale data centers have been built. We are over 1,000 now. That's every 4 years, the capacity is doubled. And one more, not so happy slide. To be able to acquire all these metals and minerals that go into the servers that are running all the software that we use, or the laptops as well, we need a number of minerals and metals, and to be able to extract them, we need to extract, for example, let's say for lead, 50 times the amount, 50 kilos of rock to be able to get 1 kilo of lead. And for silver, that's is it clear? A little bit explain. So if you think about, it's not that you go, oh, here's some gold, let's get it home. No, it's a whole process, and it has a big impact. I put that photo there because, well, I'm from Argentina. This is there are some lithium mines that the local communities are fighting against. Why? Is it because they are against technology? No, it's because there are consequences to the environment. There's pollution of the water. A lot of water needs to be used to be able to extract these minerals. So that's why when it says there, no lithium, yes to water, yes to life. I mean, I think perhaps you've heard this more often, but it's like if you are maybe we're in our world of software, but there's also material side of this. And yeah, artificial intelligence, generative AI is only making things escalate faster. This is a projection of the electricity demand for generative AI, and you see how it will explode. So a little bit one more thing about ourselves, I'm gonna stop. And this is that's our mission: sustainable cloud native infrastructure wherever you need it. It was funny because at one point we defined which the values of the company are, and then I don't know, a year later we made a survey. We do a survey every year with employees, asking, and one of the questions was, do you know what the values of the company are? Sustainability was not part of the values, but almost everybody said sustainability. And then we added it to the values of the company. Because it's emerged because it's part of what we want. We obviously, like probably all of you and a lot of people, we want to do something. And we thought we can create impacts. We're a small company, we cannot do huge things, but we can also create impact via our customers. We can, whatever we do, worst case, we bring awareness. Like I'm here today, Jasper is here, we are happy to, I don't know, at least share that there's something that we are also trying to do. It's like joining forces in a way. And we realized that we needed to start measuring, because a lot of people go and yeah, you can do this, you can do that, but how can you know if what you're doing, what's the impact? Are you improving? How much? So if you can't measure it, you can't improve it. And like Mark said, you can easily create programs to brainwash because you can't prove or measure what you're doing. So that's why we started working on the Kubernetes emissions insights tool, with the goal to understand the emissions of your cloud software. What does it mean your cloud software? So it's not just your software, but it is across the whole stack. The software and the hardware you're running and the energy consumption. Ideally, also everything on the data center is impacting. So we would like to help answer some questions. For example, for a company or a customer of ours, which applications generate the most emissions? Where would the biggest gain be? Like, would it be to start using renewable energy, so moving to another data center, or would it be, is it because I could extend the hardware life cycle and then impact positively in CO2, or can I reduce it? Or should I better focus on that, getting the most out of the energy consumption? Things like, if you compare different versions of your software, is there a regression in the emissions? Is it worse than before? I'm generating more CO2. Can I select different software tools based on their emissions? So, yeah, what we did, I mean, we looked at what was out there, because of course we don't want to build something that already exists. We are of course focusing on Kubernetes. What we found is the software carbon intensity formula. Maybe someone hear about that? No? It has, this year it was approved as an ISO standard. Did you hear?
Yes.
The
last April,
yeah.
recently.
Yes. Yeah, it considers 3 aspects. The energy efficiency is one. The hardware efficiency is another. and the carbon awareness is another. So basically, if we, it's a mathematical formula. The 3 points that I just mentioned. So first you have the E of energy consumption of the software that's running. I for energy intensity. Does anyone know what energy intensity is? You don't have to explain it, just say yes. So the energy intensity is what are the emissions caused by generating that electricity. So carbon has a high intensity versus wind energy, which has low intensity. And the third point is the M, the embodied emissions. Anybody knows what that means? Heard about it? So the embodied emissions are the emissions generated, so it's basically the hardware. The emissions generated during the manufacturing, disposal, and transportation of the hardware, where software is made. Those are the embodied emissions. And then all this is per functional unit. So ideally you could apply this and say, okay, per student, my application generates this amount of carbon, or per son. Yeah. Are there any questions about this one? Yeah.
This measurement also includes, for example, the emission cost for, let's say, producing the required devices for the digitalization itself, or
Exactly, yeah. So that would be included in the M. Yes, that would be the embodied emissions. So everything, so the emissions generated when you when the server, for example, where it's running, was manufactured, but also when the minerals and the metals were extracted. And yeah, that would be the embodied. Yeah, I hope it's a bit clear, but if not, just ask.
And then you can also see if the M, if you use your hardware for 10 years, then the M will become smaller than if you only use it for 1 year.
Oh,
So it helps you to use your hardware longer.
I see.
Because it's a constant.
Oh.
So it's basically the carbon footprint of the whole life cycle of hardware. So if it costs so much in terms of carbon, then you distribute over 1 year or 10 years, of course, the percentage is lower.
Yeah. So yeah, there will be a formula to calculate this as well.
Yeah. Thanks, Maria. Yeah. So we built this tool, like I talked about. It's mainly of its we measure in a live Kubernetes cluster on Hetzner in Germany or any AWS in Ireland at the moment. And then we have live data. So I will demo this. Yeah, I think. So this is the live dashboard. It's very small. You see it? So you see really the formula at this moment. So at the left side we have the E. So we measure the energy consumption. Sorry, it's not a live demo, it's the video.
The first column.
Sorry?
The first column, yeah.
Yeah, that is the video, it's not a live demo. Because like cursor
We share the wrong screen.
doesn't matter. So this is the E, so energy consumption of the cluster for 2 days. It's the I, the energy intensity in Ireland. So it's we get it from a tool via an API. So it's constantly fluctuating every hour because you have different sources like solar or wind or in the night only wind. And then I will share down the screen. Terrible.
Not yet.
I see that.
Yes,
Yeah, much better.
that's fine.
So this is the formula again. Now it's statements. Energy, I told you, and this is the embodiment. This is what we get from a tool called Boa Vista. So they have a huge database. We'll come to that later. And then we query our cluster. Where does it run on? Because it's dynamic. Which type of server it is in our menu because it scales. Per 2 days, and we assume that hardware is used 5 days. In AWS, this is an AWS. AWS is not so open about it. But there are articles on the internet which says it's 5 years. They extend it. I think 5 years ago it was still 2 or 3 years, so they improve also. It's good. The functional R, what Flavia talked about, so it's per student, for instance, if it's a learning platform. Here we don't do it at the moment, and this is the value. So it's 6,492 kilograms CO2, and then we can.
Here's more like per 2 days.
Yeah,
The
it's-
functional unit is not functional. But
Yeah, we for the whole cluster. But the thing is, you can something very dynamic. You can. Let's see. You can change it to 2 days. Change of course. And you can see these are the namespaces. Yeah, are you familiar with Kubernetes?
No,
Okay.
depends.
Yeah, Kubernetes is an infrastructure, cloud infrastructure. Yeah, orchestration. So that are the namespace. So you can see per namespace where your server runs, how many energy it uses. So you can zoom into every service. It's a percentage of embodied for the whole energy. So at this moment it's very low. It's only 0.5%. So the embodied part in 2 days, very low. We saw in other installation in Geurtsen in Germany was around 40%. So sometimes it's you really have to look into this. This is quite interesting, and still we don't understand it completely.
It's a bit what I was saying, that if we know where most of the emissions come from the formula, then we can focus, it's better to focus on that instead of, like blindly trying to make the software more efficient. Perhaps that's not where the most gains are.
And here you see that the cluster doesn't do much, so it's only 5% CPU at the moment. And this is the graph of 1 day of the carbon intensity in Ireland, which is quite high. It's 400 to 500. In the Netherlands, we have now around 200 in a day. But I will show you later also. But it doesn't help much for the total. This is very bad actually, Ireland. They don't have a lot of solar or wind energy.
Then the people who are running this, maybe they see that and they say, okay, we move to another region.
And that's the yeah, you
That's
can
the
look
goal.
this. Yeah. So you can say, oh, we go to Norway, for instance, with very renewable energy. So the intensity is very low. So that would be a nice move to change. Yeah, and here you can see the last thing I show the per namespace, how it's divided. But on the right side is with this common equivalent, you can fly 27 kilometers with an airplane. So it's not much. It's just kind of translation. Okay. Any questions about this? Do you want to see something more? You can select a namespace. The kite, no, it's not so interesting. But yeah, everything is typed here in constantly read.
So I missed the total, the CI total.
That is on the right.
Oh, yes.
This one. We'll change it to common. That's the wrong. About other source tools, I think you're interested in this. What we use. Yeah, what's already mentioned is Kubernetes, so everything runs in a Kubernetes cluster. So that's the cloud infrastructure orchestration. For the energy consumption of the hardware, we use Kepler. It's in the left part. That is that's pretty interesting tool. It uses the real hardware of the RAPL, it's called, from the processor. It's EBPF, it's called, I think. And it's embedded in the kernel. It's the new thing in kernel space that EBPF, everybody's talking about it. So that's interesting. In AWS, we don't have access to this. So then it's Kepler uses data models. It's trained somewhere. So if you run AWS, it's estimated. If you run on, for instance, Hesna, you have real hardware, then it's real data. Then we have Boa Vista that we use for the embodied of the hardware. So there's a huge database with all kinds of hardware, how much embodied emissions it was. Then we use electricity maps together with grid intensity Go. And then we can read out per region where we run the hardware what energy we can get. It's very interesting. I show it. And then we use Grafana like you saw just now. That's the export. And Prometheus is the one who collects all this data from those Kepler, electricity map, Boa Vista, to put it in his time series database, and then we can read it. That's the major things, Prometheus, the data collector.
So how long do you keep? How much data do you keep in Prometheus?
Currently 2 days. It's very short.
Yeah, we know.
But it's also, but we are an environment-friendly company, so we don't want to. Yeah, it should be long. Yeah, it's more interesting to see how long it is. Yeah, but in the Hesna we did 1 week, but you can do for 1 week. Yeah, you can compare seasons. For in the summer, the carbon intensity is very low because of the sun. You have a lot of solar renewable energy. And it's the graph how Kite is built. But actually, they're all here we have 3 APIs, and they call exporters. Prometheus runs by all the exporters it has in the cluster, and then it will get the data out and put it in its database. And on top of that, we build Grafana, which is quite easy to build. If you want to do this. Electricity. This is you can go to this website. I watch it almost every day. Somehow I like it. I don't know why. And you can select the country. That is Netherlands. And this is I think last Friday. And they see the whole day how the intensity is. So this was during the day. It was a sunny day. I think it's very low. And this is at the end of the day. And there you can see this is that's really nice. That's wind. The blue one is wind. The purple one is nuclear, and the big one on the bottom is gas. So, and that's also that's the thing with France. They are always green. They're very low intensity, but it's not renewable. It's nuclear. So that's good to think about. Is it renewable energy or is it?
That's a big discussion point.
Yeah. Is it really low intensity? Yeah. Sustainable. Yeah. And you see in Sweden, in the top, there's a lot of water hydro power, so they're very good or very low carbon.
Also Finland.
Finland also. And also Portugal, I was amazed. Portugal is also a lot of hydro. But you see, we just looked at the islands. Yeah, it's not good. There's a lot of coal. Yes.
Yeah.
It's a pity because there are a lot of data centers.
Yes.
But yeah, that's how you can decide where do I buy my cloud infrastructure if I set up a new application. It's very interesting. Yeah, the challenging of this, because there are a lot of estimations in this part, but at least we have a number. And we know what we measure. The estimation via measurement. If the hardware does that, this repo what I just told you, the energy consumption is estimated. Both Vista doesn't always include the end of life part, so the dispose the hardware, which is also quite intensive. About big data centers, about the hyperscalers, they are very secret about all their data centers. So they're not very open. It's a big discussion point. So, and there's a lot of them insights about it. They don't talk about water consumption. And then, there are PUE, what was the name? It stands for
Power usage efficiency.
of the data center. That is a number. The AWS is 1.135, I think they say in the literature, but you don't know. So it's not really validated, so you cannot really compare them. I think even Hetzner is 1.1. They say they have all 100% green energy. But it's if it's 1, then all the energy goes to your data center. If it's 1.5, half of the 0.5 part goes to the lighting, the office building, the cooling, all that around. So the PUE we also put in the equation in the E part. But what about the embodied emissions of the data center? Building in the data center, we don't know how big it is. How they're very secretive, the hyperscalers. No, that's what I just said. Cloud providers are not very transparent. Yeah, this is also what I said. France has a lot of nuclear. Yeah. And maybe in the Netherlands too in the future. Yeah. So you see the formula is a good starting point, but it's it's not perfect, it's not 100% correct. But it's a good starting point to compare things in the future. Versions of Favia. Okay. End of presentation. So what will you do when you build your new software in the cloud? Will you, I hope you will think about this and make good choices. Where do I get my cloud infrastructure? Do I go to Sweden or to Ireland? But every little step helps. Just think about it. Yeah. And we are a small company, around 20 people, I think, in Utrecht, and we are located in a few customers. But we do work on this next to our customer work, and we have maybe some thesis subjects. So if you're interested, please come to us.